Thank you, Matheus, and thank you, Dr. Gabriel. Professor Jacques, would you like to talk something?
At this point, I have nothing to add, except if there is some question that I can answer. Otherwise, I thank you for organizing this session.
Thank you. Question, please. Please write in English. Can you read the comments,
Sorry?
Professor? Can you read the comments?
Yeah, but I think that most of them are in Portuguese.
No, I asked you to write in English. I have asked.
In the comments. Oh, okay. I was looking at private chat. I'm going up the list. Oh boy, lots of comment.
Are you in comment chat?
Yeah, I'm just looking at the comments very quickly.
Scroll up.
Anacrestia, is the probability that the CRISPR test will give false negative results? That's a question mostly for Gabriel. Gabriel, can you answer that?
So at the moment, we don't entirely know with my test. Generally, tests similar to this one have a sensitivity of about 90%. So the probability of giving a negative result is very low because it also tends to have a sensibility of about 80 to 90% as well. So overall, it's better than some of the alternatives that exist that aren't RT-qPCR.
Okay. Another question for you, Gabriel. It's also from Anna Cristina. Does the CRISPR test apply to other disease like Ebola, Zika, or dengue?
So we actually intend to adapt the test to Ebola as soon as we can. We're toying with the idea of doing Zika, LEPS, and a few others, because all we need to do is change a few of the sequences that we're using. So the LAMP primers and the guide for the CRISPR-Cas13 protein. And at that point, we'll immediately be able to start detecting those viruses as well. So now that the test exists, it's just a matter of optimizing it for every individual virus.
Okay, there's another question from France Antarctique Nouvelle. What are the perspectives of using the CRISPR-Cas9 technology to treat HIV? I must admit I'm not an expert of HIV. I know that some groups are working on that. I don't know what are the chances that whether or not this will work. But I think this is reasonable. You know, the bacteria have been using the CRISPR-Cas9 technology since millions of years to cut the virus. And so the idea here is to use the Cas9 technology to cut the HIV virus. I think this is quite reasonable. In fact, at the beginning of the COVID-19 pandemic, I saw a group in the United States that were proposing to use the CRISPR-Cas9 technology indeed to cut the COVID-19 virus. So it's the same approach for the HIV. I think this is a reasonable approach. My lab is not working on that approach. Also from France Antarctique, can this technology substitute the antibiotic in the near future, for example, to treat multi-resistant tuberculosis? Again, I think it's a good suggestion, and yes, indeed. The main problem with these CRISPR-Cas9 technology is to find an adequate technique to deliver either the Cas9 protein or the Cas9 gene. And so far in gene therapy, what is being used is the adeno-associated virus. Unfortunately, the adeno-associated virus costs a fortune to produce in good manufacturing practice. So we have to find another delivery method to deliver either the Cas9 protein or the Cas9 gene, and then it would ease using it, because right now it would be just too expensive to be used instead of an antibiotic. Also from France Antarctique, CRISPR-Cas9 may be an option in the near future to treat COVID, Ebola, Zika, malaria. Well, all of that I think is feasible. If I would have more money in my lab, we could start working on that also. I think these are reasonable projects. Many of the comments are in Portuguese, unfortunately.
There is no question in Portuguese, only comments.
Let me
There is no question.
try to help. Is
No,
there any question in
I think
Portuguese?
there isn't.
There's
Only comments.
Yeah. I see that I vary
Okay.
between 2 and 5 stars. One question from Vitor. Is it I'd like to know if CRISPR is affordable to public health system and if it can contribute to the cost reducing of genetic therapy that already exists. The main cost of gene therapy that currently exists is the production of the adeno-associated virus in good manufacturing practice condition. The last time I looked into doing a clinical trial for systemic delivery of some gene therapy, it was about $1 million to produce enough AAV to treat one patient. So to do a clinical trial on 10 patients, you needed to start a budget of $10 million. And of course, so far I have not been able to obtain such large budget. The only people that have such large budget are American companies that will spend a fortune doing these clinical trials, and they have millions of dollars available. The problem is indeed that after the treatment has been demonstrated effective, the cost of the treatment is $2 to $3 million per person. So I think it's the future. We need to develop gene therapy for many hereditary disease, but we also need to develop a cheap gene therapy. I think ideally a gene therapy should be around $100,000, not $1 million, because most of the public health system cannot afford to do that. I think that it's only in United States where rich people can afford to pay for those, and poor people will not get access to the treatment. Still looking down for the list to see if there is any other question.
Excuse me, Professor Jacques. Just to make a small comment here, for those who doesn't speak English, I'll try to get the general idea from the answers you just gave, and Gabriel also. Just a second. As perguntas principais aqui foram se esse estilo de tratamento, esse estilo de teste poderia ser usado para outras doenças, como citaram Ebola, citaram HIV. Eu não estou muito bem lembrado das outras. Vocês se lembram, Bárbara, Werber-Bandeira? Tuberculose, sim. Zika vírus.
A substituição dos antibióticos pela técnica CRISPR.
Sim. Então, de uma forma geral, o teste pode sim ser abrangido para outras doenças, mas não necessariamente vai ser realizado agora, e precisaria de um certo investimento e um certo tempo para ser feito. Do ponto de vista do uso da tecnologia para curar algumas doenças, ele acha que é bem possível que seja desenvolvido, o professor Jacques disse isso, mas que precisaria de um investimento muito maior para que isso acontecesse, de outras pessoas também pesquisando e com o tempo. A última pergunta foi uma das mais interessantes, se seria o caso de esse tipo de tratamento ajudar, se ele custaria o suficiente para que um sistema público de saúde pudesse pagar para uma população grande, e o professor Jacques esclareceu que se houvessem laboratórios públicos desenvolvendo a tecnologia, sim, mas que provavelmente essas tecnologias vão ser desenvolvidas por grandes farmacêuticas que vão cobrar muito caro por esse processo, que talvez num futuro, não para agora, mas no futuro, seja acessível sim ao público. Okay, Dr. Jacques, thank you for your time, and is there any question, you can keep reading and answering them.
Well, Eventually, if there are other questions, people can always send me some emails.
Okay. Thank you, Professor Jacques Tremblay, for this wonderful meeting. Thank you, Gabriel. Thank you, Dr. Barbara Oliveira Hicks. Thank you, Matheus Chaves. And I hope you have another one meeting like this. Thank you very much.
Thank you.
Good night. Good night.
Thank you.
Thank you.
Have a good night.
Goodbye. Thank you.
Gostaria de agradecer a todos, em nome da FAF, pelas apresentações. Vou deixar para vocês um link lá no chat, para quem quiser emitir certificado. Esse link está disponível até às 23 horas, e é só acessá-lo e recebe o certificado por e-mail. Agradeço novamente, professor Bandeira, Matheus, professor Jacques e Gabriel, que já saíram da sala, mas agradeço a presença de todos e todos os que colaboraram com esse evento. Espero que seja o primeiro de muitos. Um grande abraço a todos e boa noite.
Boa noite.
Até mais, boa noite, um abraço.
Boa noite. Obrigado, Bárbara.
Obrigado pela oportunidade.